We're going to do partial fraction decomposition. And to give you a sense of what that is, if I give you this fraction problem and ask you to add, subtract, let's do a shortcut so you can see what. Shortcut my rocking chairs, you go like this. You get 2 times x minus 4, which is 2x minus 8, minus all of x plus 3, which is negative x, and negative 1 times 3, negative 3, all over the product of the two. So over here you have x plus 3 times x minus 4. That gives us the answer. 2x minus x is x, negative 8, negative 3, negative 11 over x plus 3, x minus 4. When we go in this direction, we are adding or subtracting fractions. When you go in the opposite direction, when you go from the given answer back to the addition subtraction problem it came from, that's called partial fraction decomposition. So going from the result, which is one fraction, to where it came from, that's partial fraction decomposition. We are going to be given fractions and we don't know what two fractions were added or subtracted to come up with the result, and that's what we have to do. Why is it we're going to do this? Well, to give you a sense, if I give you this integral to evaluate, you look at what to do here and you say, well, I don't know what that is. If I multiplied x plus 3 times x minus 4, this is x minus 11 over x squared minus x minus 12. And I guess I would have to do something with a u substitution, but my only choice for u would be the denominator. It looks like it's going to get complicated. You could work that. However, with partial fraction decomposition, this problem becomes, this is, kind of, hard. This problem becomes much easier because I can now rewrite this fraction as 2 over x plus 3 minus 1 over x minus 4. And now that integral is much easier. This becomes a much easier problem because it's 2 over 1 over x plus 3, which is a logarithm, minus 1 over x minus 4. And with u substitutions, where u is x plus 3 and du is dx, this is just 2 log x plus 3 minus log of x minus 4. So that is why we're going to be doing decomposition. We want to take complicated fractional expressions and decompose them, and it's going to give us easier integrals to work. I'm going to show you the technique. Let's assume you did not know the answer to x minus 11 over x plus 3, x minus 4. We're going to start with x minus 11 over quantity x plus 3, x minus 4. If we think about this, this came from adding two fractions. We don't know what those are, but we know that when you add two fractions, the only way you can get this denominator, x plus 3 times x minus 4, is if one of the fractions denominators was x plus 3 and the other was x minus 4. We don't know what number here, so we'll call it A, and we don't know here, so we'll call that B. And A and B have to be numbers, and just so you see, I couldn't have AX over x plus 3 plus B over x minus 4. The reason for that is when I cross multiply, I would have AX squared as one of the terms, and I do not have an x squared here. So that tells me A and B have to be numbers. They can't be A times an x value. I'm just going to add these two fractions, And I know they're going to look like this. I get x minus 11 over x plus 3, x minus 4 equals a times this. So I have a times x minus 4 plus b times x plus 3 all over x plus 3, x minus 4. But I have two denominators are the same, so for the two fractions to equal them, the two numerators must be equal. With the two numerators equal, that's going to give me the sentence that I'm going to solve. That tells me that x minus 11 has to equal this numerator, a times x minus 4 plus b times x plus 3. And it must equal that no matter what x value I substitute in. We'll go on to the next page. There actually are going to be two ways, two methods to actually solve this. The first method I call the substitution. Maybe I'll call it the substitute values method. Since x minus 11 has to equal this numerator here for any x value, I'm going to choose two x values that are going to help me find those values of a and b. I'm going to let x equal 4, and when I let x equal 4, I get 4 minus 11 is a times 4 minus 4 plus b times 4 plus 3. The reason I did that is I want to zero this out. So I get negative 7. 4 minus 11 is negative 7 is 7b. So that tells me b equals negative 1. Then to make this zero out, I'm going to let x equal negative 3, and I get negative 3 minus 11 must be a times negative 3 minus 4 plus b times negative 3 plus 3. And I did want this to zero out. So I have negative 14 is negative 7a, so a is 2. And isn't that what we had, you guys? So now we're going to plug that in. Look what we get. So now we are going to plug into the original. Okay. All right, so here's the second method, is the coefficients method. Let's do this one. Isn't this a longer one? I don't like this as well, but some people do. When we do like them is when we mix quadratics. So do you guys remember, how would you solve this? Do you remember reviewing how we solve system of equations with two unknowns? We have negative 4a plus 3b. I am going to multiply the top by 4. 4 is 4a plus 4b, and then we get negative 11 is negative 4a plus 3b. And sure enough, we get negative 7 is 7b. So from there we get b is negative 1. And when we put that in here, we get 1 is a plus negative 1. So a becomes 2. And we get the same result.